Welcome back, everyone, to the Deep Dive.
Hey there. Good to be diving in.
Today, we're tackling something really becoming essential for machine learning engineers, how to actually master n8n to, elevate your MLOps game.
Yeah, it's more than just another tool these days.
Right, because being an ML engineer now, it's way beyond just model training. You're dealing with this whole complex ecosystem.
Exactly. Data pipelines, API integrations, automating deployments, keeping an eye on things with monitoring, MLOps, the whole shebang.
But, the challenge is finding the right tool. A lot of the workflow automation stuff out there is either, well, too simple for what technical folks need.
Or way too rigid, locks you into their way of doing things.
Precisely. And that's where n8n comes in. It feels like it's built for technical teams.
Yeah.
People who want the speed of visual building but still need the power and precision of code.
That's a great way to put it.
And for ML engineers specifically, it hits some sweet spots, right? Like self-hosting.
Huge. Absolute control over sensitive data. Compute. That vital.
And extensibility, being able to drop in custom JavaScript or Python using libraries like pandas directly.
Oh, yeah. That opens up so much.
Yeah.
Plus, the native AI stack is pretty sophisticated now for building those agentic systems.
It really positions n8n not just as like a connector tool, but more like a whole framework.
Exactly. It's for orchestrating those complex data flows that underpin modern machine learning. It feels more like a development environment, really.
So our mission today is to walk through, conceptually, an intensive 15-day curriculum. Think of it as a roadmap.
From novice to expert.
Right. Building that deep architectural understanding, moving from the core ideas right up to real-world MLOps and even AI applications. It's about achieving genuine mastery.
Sounds like a plan. Where do we start?
Okay, let's unpack this journey, starting with the absolute foundation, n8n's architecture and its core concepts. Whenever you're learning a new tool, really understanding how it works inside. That's step one.
Absolutely. And you need to shift your thinking. Don't just see it as a visual tool, but as a complete development framework. That's key for mastery architecting systems, not just connecting boxes.
So what are those fundamental building blocks?
Okay, you've got workflows. That's your main canvas.
Right, where you build the automation.
Then nodes. These are the actual action blocks, the steps.
Like API calls, data transformations.
Exactly. Connections link those nodes, showing how the data flows. Then execution, super important. These are the records of every time your workflow runs. Essential for debugging.
Ah, okay. Like a log file, but structured?
Precisely. And finally, credentials. Secure, reusable storage for things like API keys, passwords, intentionally kept separate from the workflow logic itself.
For security makes sense, and reusability too, I guess.
Definitely. Now, the architecture itself, you can break it down into three main parts. First, the n8n editor, that's the UI, the front end you work with.
A visual part.
Right. But what it's doing is generating a JSON representation of your workflow. And that's key for engineers because it means your workflows. They can be version controlled in Git, programmatically generated, manipulated outside the UI.
Ah, so workflows are code, just represented visually.
In a sense, yes.
Mm-hmm.
Then there's the workflow execution engine, the back end. This is the heart. It takes that JSON, runs it step by step, manages the data flow, handles errors, logs the executions.
Okay.
And it can run in different modes, like queue mode for distributed execution, which we'll touch on later for scaling.
Got it. And the third part?
The database.
Mm-hmm.
n8n needs somewhere to store its state. Workflow definitions, those encrypted credentials, execution logs, user info.
Right.
It defaults to Spoil it,
Yeah.
which is fine for getting started, just playing around.
Yeah.
But for any serious production work, you absolutely need something robust like PostgreSQL or MySQL. n8n supports and recommends those.
That dev versus production distinction is crucial. Which brings us to deployment. Cloud versus self-hosting. You mentioned self-hosting is often preferred for ML.
Yeah, I think so. It gives you maximum control over your data, your security, the environment itself. You get complete data privacy, often non-negotiable for ML.
Right, dealing with sensitive data sets.
And you can customize it deeply, like installing specific Python libraries needed for your models or data prep right into the execution environment. Plus, the Fair Code license means it's free for internal use.
Pretty compelling. So in this curriculum, like on day one, the first project is actually setting up a self-hosted Docker instance with PostgreSQL.
Exactly. Get that production grade setup right from the start. Instill best practices. Then you build a super simple workflow. Manual trigger, set node saying, hello, n8n, just to see it run and see data flow. Your first win.
Okay, makes sense. Get the foundation solid. So now we understand the core parts, how to deploy, but how do workflows actually start? We need triggers, right?
Precisely. Triggers are the entry point.
When they need to talk to other services, they need those keys to the kingdom credential.
Yep. So triggers first, you've got the manual trigger, great for development, testing, running things on demand.
Your basic run now button.
Basically. Then the schedule trigger for time-based stuff, nightly data jobs, hourly checks, uses standard cron syntax.
Okay, familiar.
But the real workhorse for event-driven automation is the webhook trigger. It gives you a unique URL. External systems send HTTP requests there, and boom, your workflow kicks off in real time.
Ah, so that's how you integrate with external events.
Exactly. And it's important to know there's a test URL for when you're building in the editor and a separate production URL for when the workflow is active. NA even has a neat built-in tunnel service for local development, so you can test webhooks without deploying.
Oh, that's handy. Avoids deploying just to test a webhook.
Super handy. Finally, there are app event triggers. These are more specialized, listening for specific events inside third-party apps, often using polling or registering webhooks automatically for you.
Got it. So once it's triggered and needs to, say, update a GitHub issue or post to Slack, it needs credentials. How does NA handle those securely?
The system is built around separation of concerns. Credentials live completely separate from your workflow logic.
Okay.
You create a credential once like your GitHub token, and then reference it in any workflow that needs it. Good for security, obviously, but also means when you export a workflow JSON, the sensitive secret isn't included.
Ah, smart. So you can share workflows without leaking keys.
Exactly. And creating them, you can use the UI, sure. But crucially for engineers, you can also create them programmatically via the REST API. Think CI/CD pipelines, provisioning credentials, or building a sauce on top of n8n.
Right, automation for the automation tool.
Precisely. And it handles loads of authentication types out of the box. Simple API keys, complex OAuth 2 flows. It even handles token refreshes automatically, which can be a real pain otherwise.
So putting that together, day 2 project, a GitHub repo monitor sending Slack notifications.
Perfect example. You get hands-on with a webhook trigger, integrating multiple apps and managing those credentials securely. You'd set up GitHub and Slack credentials, configure the n8n webhook node, link it in GitHub, and then you use expressions, we'll get to those, to pull out issue details and craft a dynamic Slack message. Real-time, secure interaction.
Okay, triggers, credentials. Now, the data itself, how does data actually move, and what does it look like inside n8n? You mentioned this is critical.
It really is. This is probably the single most important concept that separates someone just using n8n from someone who truly understands it. The data structure.
Okay, lay it on us.
Data flowing between nodes in n8n is always passed as an array of objects.
An array of objects. Okay.
Each object in that array represents one item. Think of it as a single unit of work passing through. And the actual data payload, the stuff you usually care about, it's expected to be inside a property named JSON within each item object.
So item.json.your data field.
Exactly. JSON field 1, value 1, JSON field 1, value 2, that kind of structure. Understanding this array of objects with a JSON key structure is absolutely critical, especially when you write custom code or debug complex flows. You have to know what the data looks like.
Got it. Array of items. Each has a JSON property. And how do you actually access that data dynamically within nodes?
That's where expressions come in. They're your superpower, wrapped in double curly braces.
Okay.
You can easily access data from the current item, like json.email, or data from a previous node using its name, node name, json.property.
Ah, so you can pull data from earlier steps.
Yep. Working with arrays within your JSON. Standard zero-based index, json.hobby. And they're handy helpers, like .first or last.
Nice.
For more advanced stuff, like in a code node, you can access the entire list of items from a previous node using item's node name. Then you can use standard JavaScript array methods like .map or .deduce on the whole dataset.
Okay, getting powerful now.
And simple JavaScript works directly in expressions, like JSON.price 1.2. Plus, JSON stringify is your best friend for debugging complex nested objects. Just output it to see the structure.
Makes sense. So the day 3 project API data dissection is all about practicing this.
Exactly. Get your hands dirty with nested JSON and expressions. You'd use a manual trigger, hit a public API like request.end with an HTTP request node to get, say, a list of users.
Okay.
Then use an edit fields node, we'll talk about that next, to add new fields using expressions, like calculating user count with json.data.length, or having the first user email with json.data.email, or even creating a comma-separated list of all last names using something like json.data.map. Really forces you to navigate that structure.
Right, really internalize how to pull out exactly what you need. Okay, so expressions are powerful, but you hinted at built-in nodes for common transformations. So you don't always need expressions or code.
Precisely. Knowing when not to write code, or even complex expressions, is key to building clean, maintainable workflows. n8n has a great suite of data transformation nodes.
What are the main ones?
The edit fields set node is your absolute workhorse. Adding fields, changing existing ones, removing them. Like a JavaScript map operation, but visual.
Okay, modify data within an item.
Yep. Then split out, this is for unnesting. Got one item with an array of 10 things inside. Split out turns it into 10 separate items, each with one of those things. Flattening data.
Ah, useful for processing list items individually.
Exactly. Aggregate is the opposite. Takes multiple items and groups them back into a single item, like a reduce or a SQL drew PBY.
Okay, split out, process aggregate, common pattern.
Very common. Then merge. This is n8n's version of a SQL join. Combines data from two different input branches. Can append data, or combine based on a common key, or just by position.
Joining data streams, got it.
Filter is straightforward. Conditional logic. Only lets items through that match your conditions.
Simple filtering.
And remove duplicates. Cleans up data based on specific fields you choose.
Nice. So the Day 4 project uses these. A simple ETL pipeline.
Yeah, simulates a classic data engineering task using only these no-code nodes. You'd mock up some data, maybe users in one node, teams in another. Use merge to combine them based on teamed enriching user data.
Okay, like adding the team name to each user record.
Right. Then maybe filter to keep only users in the engineering team. Then edit fields set to clean up the final structure. Maybe just keep employee name and department. And finally, load it into a Google Sheet. Shows a full extract, transform, load flow visually.
That's cool. Seeing ETL without writing SQL or Python scripts. Okay, so we can transform data. What about controlling the flow itself, making decisions, handling loops? You mentioned n8n has a unique take on looping.
Yeah, this is where programmers sometimes need a mental shift. You have to embrace n8n's preference for implicit item-based processing over explicit for loops you might be used to.
Implicit looping, how does that work?
We'll get there. First, conditional logic. The main tool is the if node. Basic binary decision, true or false output. You set conditions, combine them with and/or. Simple branching.
Okay.
For more complex, multi-way branching, like a switch.case statement in code, you use the switch node. Much cleaner than nesting lots of if nodes. Routes items to one of several output paths based on rules.
Got it. IF for two paths, switch for many. Now looping.
Right, so implicit looping is the default. Most n8n nodes are designed to run once for each item they receive as input.
Oh, okay.
If a node gets an array of 5 items, it executes its logic 5 times, once for each item, automatically. You don't usually build a loop around the node. The stream of items is the loop.
So the workflow itself kind of acts like the loop body processing each item.
Exactly. For a huge number of cases, you simply don't need an explicit loop structure. But sometimes you do. That's explicit looping, using the loop over items node.
When would you need that?
Specific scenarios, like batch processing. Breaking a massive data set from a database into smaller chunks of, say, 100 items each, to avoid hitting API rate limits or overwhelming memory. You'd loop in batches.
Makes sense. Process chunk by chunk.
Or explicit rate limiting. Put a wait node inside the loop to pause between API calls. Or dealing with certain nodes that are designed to only process the first item they receive, you might loop explicitly to feed them one item at a time.
Okay. And aggregating results after an explicit loop.
Common challenge. You typically need an aggregate node or maybe a code node after loop finishes to gather up the results for each iteration.
Right. So the Day 5 project, customer onboarding logic, uses this flow control.
Yeah, it uses the switch node nicely. You mock up customer signups with different plans, free, pro, enterprise. The switch node directs them based on the plan field.
Okay.
The free branch might send a welcome email. Pro creates a task in Notion for the account manager. Enterprise sends an urgent Slack message. Different actions based on the condition.
And
then you use a merge node in append mode to bring all those paths back together, maybe just to log every action taken into a single Google Sheet. Shows branching and merging clearly.
Okay, that covers the foundational stuff really well. Architecture, data, transformations, flow control. But you said this is where n8n starts to really shine for ML engineers, extending it with code and AI.
Absolutely. We built the base. Now we add the power-ups. This is where n8n goes from just automation to a proper development environment for ML tasks.
Let's start with the code node. You called it the gateway to unlimited power. When do you actually step outside the visual nodes and write JavaScript?
Good question. It's a strategic choice. Use the code node when n8n. Data transformations get really complex, too messy for built-in nodes. When you need custom business logic that doesn't fit standard nodes, sometimes for performance, consolidating many small steps into one code block. And crucially, when you need to interact with an API that doesn't have a dedicated n8n node yet, the code node effectively turns n8n into this serverless JavaScript execution environment orchestrated by that visual graph. Best of both worlds.
And writing JavaScript there, pretty standard. Accessing data is straightforward.
Yeah, you get the incoming item as item.json or input.agent.json. If you need all items, that's items or items. There are built-in helpers, like this .helpers.http request for making authenticated API calls easily.
But the key thing is the output format, right?
Absolutely critical. You must return data in that n8n format, an array of objects, each having a JSON property. So return json.outputData.value. Get that wrong, and the workflow breaks downstream.
And the execution modes, run once per item versus run once for all.
Super important distinction again. Default is run once for each item, good for transforming items individually. Run once for all items is what you use when you need to process the entire data set together, like for aggregations or completely restructuring the output. Choosing the right mode affects logic and performance.
So day 6 involves refactoring that earlier ETL pipeline into a single code node.
Exactly. Direct comparison. You feed the raw user and team data into one code node, set it to run once for all items, then write JavaScript inside that replicates the merge, filter, and set logic you did visually before.
What's the takeaway?
Trade-offs. No code is visual, easy to grasp initially. The code version is more compact, encapsulates all the logic in one place, and might be more performant for really complex stuff. Shows you have options.
So JavaScript is powerful, but for most ML engineers, Python is home base. How does n8n handle Python?
This is huge. n8n's ability to execute Python code and, crucially, use external Python libraries, that's transformative. You just switch the code node's language to Python.
Right, and data.
Input data comes in as a list of Python dictionaries. Your script does its thing, and you're expected to return a list of dictionaries. n8n handles the JSON to dictum-back serialization automatically.
Okay, but the libraries, pandas, NumPy, scikit-learn, how do you get those?
This is the critical part. Only works on self-hosted instances. You configure your n8n environment, usually in the docker-compose.nml file, by setting specific environment variables like no defunctionalo external and listing the packages you need, like pandas and NumPy.
Ah, so you define allowed packages at the environment level.
Right. Once you've done that and restarted n8n, you can just import pandas as PED in your Python code node and use it exactly like you normally would. It unlocks the entire Python data science ecosystem inside your n8n workflows.
That is a game changer. So day 7 project, data analysis with pandas.
The classic task. You'd modify docker-compose.aml, restart n8n, fetch a CSV file with an HTTP request node, making sure to get the raw file data. Connect that to a Python code node.
Okay.
Inside, your Python script reads the binary CSV data, maybe using io.bytes.io and pandas, performs some analysis like grouping by a category, calculating a mean, and then returns the results as that list of dictionaries. Seamless integration of serious data science libraries into your automation.
Wow, okay. That bridges a massive gap. Now, let's talk AI. n8n isn't just connecting things anymore. It has its own AI stack.
Yeah, it's evolved significantly. It now has a native high-level AI stack, quite influenced by frameworks like LangChain. It abstracts away a lot of the boilerplate code you'd otherwise need for building AI agents or complex LLM pipelines.
Making it more visual and modular?
Exactly.
Yeah.
And much easier to debug when you can see the data flowing into and out of each AI component.
So what are the core building blocks, the AI nodes?
You've got the AI agent or conversational agent node. This is the brain, the orchestrator. It intelligently decides which tools to use.
Tools.
We'll get to that. Then LLM nodes. Specific integrations for different models, OpenAI, local ones via Llama, Google Gemini, Mistral. They provide the reasoning and language generation.
Okay, the actual language model.
Vector store nodes. These provide long-term memory or a knowledge base. Think Weaviate, Qdrant, Pinecone. Essential for retrieval augmented generation, or array.
Right, giving the AI access to specific documents.
Memory nodes manage short-term conversational history, like remembering the last few turns of a chat. And tools. This is a really powerful concept in n8n's AI stack. Any other n8n node or even an entire separate n8n workflow can be designated as a tool for the agent.
Whoa, okay. How does the agent know which tool to use?
You give each tool a description. The AI agent uses its LLM brain to understand the user's request and figure out which tool, based on its description, is the best fit for the job.
That's clever. So the Day 8 project, a local AI research assistant, uses this.
Yep. Perfect intro. You'd need Docker and a Llama running locally. Start with a chat trigger node. Connect it to an AI agent node.
The brain.
Right. Connect an Llama chat model node to the agent's LLM input. Then create an HTTP request node, maybe set up to call the Wikipedia API. Connect that node to the AI agent's tools input.
Making the Wikipedia search a tool.
Exactly. And you give it a clear tool description, like searches Wikipedia for information on a topic. Define the agent's overall goal, its system prompt. Then you run it, ask, what is machine learning? The agent uses Llama to figure out it needs the Wikipedia tool, calls it, gets the info back, and then uses Llama again to synthesize a nice answer. A complete tool-using agent loop, all visually debuggable.
That's fantastic, seeing the agent decide and use tools. And that sets us up for RAG, Retrieval Augmented Generation.
Perfectly. RAG is huge right now. It tackles the LLM hallucination problem and knowledge cutoffs by feeding the model relevant information from your own documents just before it generates an answer.
So it answers based on specific context you provide.
Precisely. It involves two phases: ingestion, getting your documents indexed into a searchable vector store, and retrieval and generation. When a user asks a question, the system retrieves relevant chunks from the vector store and provides them, along with the original question, to the LLM.
And in n8n, you build this as two workflows.
Usually the cleanest way. First, an injection workflow, triggered manually or maybe by a new file landing in Google Drive. It loads the document, chunks the text, often using a code node for sophisticated splitting, generates vector embeddings using an LLM node, and then updates or inserts those embeddings and the text into a vector store node, like qdrent.
Okay, that populates the knowledge base.
Then the querying workflow, typically using a chat trigger. It has an AI agent node. The key part is adding a retriever tool. This is usually your vector store node configured for search. When the user asks a question, the agent uses this tool.
How does the tool work?
Under the hood, it takes the user's question, creates an embedding of vector, searches the vector database for similar vectors, representing relevant text chunks, and returns those chunks. The AI agent then cleverly crafts a prompt for the main LLM that includes the original question and the retrieved context.
So the LLM gets asked, based on the specific information retrieved context, answer this question user's question.
It's exactly. Leading to accurate, context-aware answers grounded in your documents. And again, seeing each step chunking, embedding, retrieval, final prompt generation visually, n8n. Hugely helpful for debugging.
So the Day 9 project, Ask My Docs chatbot, builds this whole RAG pipeline.
Builds both workflows: ingestion, manual trigger, HTTP request to grab markdown docs, maybe n8n's own docs from GitHub, code node for chunking, a Llama for embeddings, qdrent node to upsert.
Okay, knowledge base loaded.
Querying, chat trigger, AI agent node using a Llama. Add another qdrent node, this time configured as a retriever tool connected to the agent. Then you ask a specific question like, how do I use the IF node? The agent uses the qdrent tool, finds relevant docs, and the LLM answers based on those docs. You've built a working RV system.
That's incredibly powerful. Okay, so n8n isn't training models, but it's the glue for everything around the model, the MLOps part.
Exactly. Its power in ML is automating the data flows around your models. Data collection, pre-processing, triggering training, creating API endpoints for inference, monitoring predictions, post-processing. It connects the MLOps loop.
And the most common pattern is just using the HTTP request node to talk to a deployed model's API endpoint.
Yep, that's the standard way.
Yep.
n8n orchestrates the calls to your model.
What are some typical MLOps workflow patterns you'd build?
Okay, a real-time inference pipeline. Webhook trigger gets new data, like a customer review. Code node cleanse formats it. HTTP request sends it to your model API. An IF or switch node then acts on the prediction, e.g., route positive sentiment to one place, negative to another.
Okay, event-driven inference.
Or a batch inference pipeline. Schedule trigger runs nightly, fetches records from a database, maybe uses that loop over items node to process in mini batches, calling the model API for each batch, writes results back to the database.
Got it for large data sets.
And data collection labeling. Use HTTP request nodes to scrape or pull data. Use transformation nodes to clean it up, then push it via API to a database or maybe a data labeling platform like Label Studio.
So the Day 10 project, Live Sentiment Analysis Service, ties this together.
It's a great example. Assume you have a simple sentiment model served via fast API locally, the n8n workflow. Webhook node is the public API. Code node formats the incoming text. HTTP request calls the local fast API model endpoint. If node checks the prediction.
And acts on it.
Right. Positive prediction. Send a Slack message to #customer_kudos. Negative. Create an item in a Notion database for review. It's a live, automated MLOps pipeline doing real-time inference and taking action, all orchestrated by n8n.
Okay, amazing progress. Building, intelligence, MLOps, pipelines. But prototypes aren't production. The final leg is about hardening these automations, making them resilient, scalable, maintainable.
Exactly. This is where the focus shifts to those critical non-functional requirements, treating n8n not just as a tool you run sometimes, but as a core piece of infrastructure that needs to be reliable.
First hurdle, scaling. How do you make sure NAN can handle, say, thousands of workflow executions per hour without falling over?
Two main ways. Vertical scaling, bigger machine, more CPU RAM. Simple, but hits limits. Or horizontal scaling, scaling out, distributing work across multiple n8n instances. This is where n8n's queue mode comes in.
Queue mode, how does that work?
It turns n8n into a distributed system. You have three parts, one main process. It handles the UI, the API, receives triggers, but doesn't execute the workflows itself. It just puts jobs onto a queue.
Okay,
Second, a message broker, usually Redis. It manages that queue of
a
jobs.
standard message queue.
Yep. And third, multiple worker processes. These are additional n8n instances whose only job is to pull workflow executions off the Redis queue and run them. You can scale the number of workers up or down based on load.
Ah, so the main instance takes requests, workers do the heavy lifting. Clever.
It's a standard distributed processing pattern. Configuration involves setting executions mode queue in n8n, pointing to Redis and your database, like PostgreSQL. You can also control concurrency setting limits on how many jobs run globally or per worker. And for high volume, data pruning is essential and alpacally deleting old execution logs to keep the database lean.
So day 11 is about load testing this queue mode setup.
Exactly. Modify your docker-compose.aml to add Redis and, say, 3 n8n worker replicas, then use a tool like K6 or Artillery to hammer a simple webhook workflow with requests. Watch the worker logs, see the executions pile up and get processed in the UI. Direct proof of the distributed system handling load.
Seeing is believing. Okay, scaling needs security. How do you lock down a self-hosted n8n instance properly?
Multi-layered approach. Network security. Never expose an 8n directly. Put a reverse proxy like nginx in front. It handles SSL/TLS termination, HTTPS, and acts as the gatekeeper. Use a firewall to block all ports except 8n8443 for the proxy.
Standard web app security.
Yep. Secrets management. Don't hard code. Use a .env file at minimum and keep it out of Git. For serious setups, n8n integrates with external systems like HashiCorp Vault or AWS Secrets Manager. Centralized, auditable secrets.
Much better.
And user management RBAC. Especially in teams, use role-based access control, available in enterprise plans, for granular permissions.
Yeah.
Who can see what? Who can edit? Who can run workflows? Essential for governance.
Makes sense. And for engineers, treating workflows like code. GitOps.
This is huge. Realizing n8n workflows are just JSON files changes everything. They should be managed in Git, just like your application code.
Benefits being version history, code reviews via pull requests.
Exactly. Single source of truth. It enables CI/CD for automation, a GitOps pipeline. You commit a change to your workflow JSON in Git. A pipeline runs, automatically deploys that updated workflow to your n8n instance using the n8n API or CLI. Discipline, auditability, automation for your automations.
Cool. So day 12 project, build that pipeline.
Yep. Export your RAG workflow JSON, put it in a GitHub repo, write a simple shell script, deploy.esh, using the n8n API, needs an API key you generate in the UI, to push that JSON to your instance, creating or updating and activating the workflow. Run the script, simulate deployment. Shows a repeatable, automated process, ready for GitHub Actions or similar.
Very nice. Bringing software engineering best practices to automation.
Okay, we've used the code node. What if we need something really custom, like a new integration, or simplifying a complex task for the team? Custom nodes. Exactly, that's the ultimate extension. Why build one? Maybe a service you use has no official n8n node, or you want to abstract away complex logic into a simple, reusable block for your team, or simplify the UI for a common task, or even contribute back to the n8 community.
How do you build them? Are there different ways?
Two main styles, declarative and programmatic. Declarative is easier for simpler cases.
Let's start there. Declarative stuff.
It's mostly JSON-based configuration within a TypeScript file. Ideal for nodes that are basically just wrappers around standard REST APIs with simple CRUDO, create, read, update, delete operations. You define the node's UI properties, its operations, and how they map to API calls using structured configuration. Minimal actual code needed.
Setting it up.
Use the n8n node starter template, npm install, then npm link to make your developing node available in your local n8n instance for testing.
So day 13 project, build a simple node for api.publicapus.org.
Perfect example. Create the .node.ts file. Define display name, basic info, define an operation like get APIs with a UI property for category. Then, the core is declarative. Request default sets the base URL, and the routing object maps the operation and its category property directly to a GET request on entries with a query parameter. Build, link, test. You've made your own node.
That feels achievable, but for more complex stuff, programmatic.
Right. The programmatic style uses TypeScript. You choose this when the logic is complex. Maybe you need multiple API calls sequentially, or conditional calls based on input, or significant data manipulation of the API response inside the node. Custom authentication flows, interacting with non-REST systems.
So you write actual code to handle the node's execution.
Exactly. The heart is the async execute method. Inside there, you write TypeScript code, you access input data, node parameters, the UI fields, credentials, use helper functions like this, .helpers.request with authentication. You have full control. But you also need robust error handling try.catch blocks, throwing proper node operation error for good user feedback.
Day 14 project then builds on the previous one, an advanced version.
Yep. Refactor the Day 13 public API node to be programmatic. Remove the declarative request defaults and routing. Implement the execute method to manually build and send the API request using helpers.
Okay, replicating the simple case first.
Then add a more complex operation, like check health. This requires multiple API calls within the execute method. First, call entries to get APIs in a category. Then loop through the results, making a second API call for each API to a hypothetical health endpoint. Collect the results, maybe return a summary. This multi-step logic clearly shows why programmatic is sometimes necessary.
Right. The declarative style couldn't handle that kind of internal looping and logic. Okay, we've covered an incredible amount. Foundations, code, AI, MLOps, scaling, security, custom nodes. Let's bring it all together. A capstone project reflecting the n8n expert mindset.
Exactly. This final project isn't just about features, it's about architectural thinking. Designing for resilience, applying all the best practices, solving a complex problem by synthesizing everything. Multiple workflows, data flow, AI code, scaling, security, extensibility.
What defines that n8n expert mindset?
Key principles. Modularity, break big problems into smaller, reusable sub-workflows. Reusability, design generic workflows triggered by others using the execute workflow node. Don't repeat yourself. Error handling and resilience, anticipate failure. Use try.catching code, use the continue on fail option strategically, build dedicated error paths for alerts, and observability design for monitoring. Clear node names, use sticky notes for documentation within the workflow, ensure execution logs are meaningful.
Makes sense. Build robust, understandable systems.
So the Day 15 capstone, a complete MLOps automation pipeline.
Yep. Automating a critical part of the continuous training and deployment loop. It uses two distinct workflows.
Okay, workflow 1.
Model training trigger starts maybe with a Google Drive trigger watching for training data.csv or a webhook. A Python code node uses pandas to validate the data schema if it fails. Slack error notifications stop if passes. HTTP request node triggers an external training service API, like starting a Kubeflow pipeline or SageMaker job.
Okay, triggers training if data is good. Workflow 2. Model deployment gate. Triggered by a webhook. Called by the training service when done, passing back the new model path and accuracy metrics. A PostgreSQL node fetches the accuracy of the current production model. An AVF node compares the new accuracy with the production accuracy.
Decision time.
Right. True branch, new model is better. HTTP request or SSH node calls the deployment script. Slack node sends success message to #deployments. False branch, new model not better. Slack node sends a deployment rejected message.
Wow. That really ties everything together. Multiple triggers, data handling, Python code, external services, conditional logic for a core MLOps decision.
It's a comprehensive demonstration. Shows mastery across the board, addressing a real ML engineering challenge.
To stepping back, what's the big picture here? We went from n8n's core ideas and visual building, through custom code, building AI agents with RG, all the way to production grade, scalable, secure MLOps pipelines, and even custom nodes. It really transforms n8n from just a simple tool into this powerful, flexible framework for ML engineers.
Absolutely. This deep dive equips you with the architecture, the skills, and importantly, that engineering mindset to build sophisticated, resilient systems that genuinely speed up your MLOps work.
Here's a final thought then. If n8n lets ML engineers visually orchestrate these incredibly complex AI and MLOps pipelines, but with the full power and precision of code always available, does it suggest a future where maybe those lines between low code and deep code start to blur, Could it invite more engineers to build faster with less boilerplate? Maybe rediscover some of the, I don't know, joy of discovery and automation?
That's a fascinating question. And on a final note, remember that knowledge is best when applied. The automation space changes constantly. Continuous learning, exploring different perspectives. That's the mark of a real expert. There's always more.
Absolutely. We really hope this deep dive gave you a powerful shortcut to understanding an n8n's potential. Check out the official docs, the community forums are great, and maybe even share your own workflows or build a custom node.
Yeah, get involved.
Until next time, keep diving deep.